AWS Cloud Practitioner Certification, Technology section, Networking. Topics covered: VPC, Subnet, Internet Gateway, Network Access Control List, Security Group, VPN Connection, Virtual Private Gateway, AWS Direct Connect, Route 53, and DNS. First topic: Amazon Virtual Private Cloud, also known as VPC. VPC is a virtual network dedicated to your AWS account. It is logically isolated from other VPCs in AWS. In other words, a VPC is your own network within AWS where you can launch AWS resources. Next topic: regions versus VPC. Let's take a look at how a VPC is associated to a region and availability zones. Previously, we discussed that a region is a separate geographic area, and an availability zone is a data center within a region. Where does VPC fit? A VPC exists within a region and it spans all the availability zones within the region. Each region comes with a default VPC. If you need, you can create additional VPCs. Next topic: Subnet. A subnet is a subnetwork exists within a VPC. Now we can see that a VPC is the container for subnets. It has a range of IP addresses. Next topic: Subnet versus availability zone. Let's take a look how a subnet is associated with an availability zone. A subnet exists within an availability zone. It cannot span multiple availability zones. When you create AWS resources, you create them within a subnet. You cannot create them outside a subnet. The recommendation is resources should be created at least on 2 subnets so that the application will not fail if one subnet fails. This is the same concept as creating resources on multiple availability zones. Next topic: Subnet types. There are 2 types of subnets, and they are public and private subnets. Public subnets have access to the internet, and private subnets don't have access to the internet. Next topic: Internet Gateway. If you want to allow internet traffic into a VPC, you have to attach an internet gateway to the VPC. The default VPC of a region is already associated with an internet gateway. But for custom VPCs, if you want to allow internet traffic in, you have to attach an internet gateway. Next topic: Public and private subnets. A public subnet is associated with an internet gateway which is attached to the VPC. What are the use cases of public and private subnets? Resources that need to be accessed by public internet have to be placed in a public subnet. For example, a website. Resources that should only be accessed within the VPC should be placed in a private subnet. For example, a database. All the subnets in a VPC can communicate between each other. So the website in the public subnet can communicate with the database in the private subnet. Next topic: Network Access Control List, also known as Network ACL. We have talked about network ACLs in the security section. Here we are going to review them. A network ACL is a virtual firewall that controls inbound and outbound traffic at the subnet level. A network ACL is created within a VPC and can be associated with one or more subnets. However, a subnet can be associated with only one network ACL. A VPC comes with a default network ACL. If you need, you can create additional network ACLs. If a subnet is not associated with a specific network ACL, it is automatically associated with the default network ACL. Next, let's take a look at how network ACLs handle traffic. By default, a default network ACL allows all inbound and outbound traffic, but you can add any rule. Custom network ACLs, by default, deny all inbound and outbound traffic. You have to explicitly allow traffic. A special feature of network ACL is that it has an explicit deny rule, which allows you to explicitly deny traffic. Another important thing is that network ACL packet filtering is stateless. This means both inbound and outbound traffic is checked independently. For example, if the traffic is allowed in, it is not automatically allowed out. Next topic, security group. A security group is a virtual firewall that controls inbound and outbound traffic of AWS resources such as EC2 instances. Remember that network ACLs are in the subnet level. In contrast, security groups are in the resource level. By default, a security group denies all inbound traffic and allows all outbound traffic. You have to explicitly add a rule to allow traffic. Unlike a network ACL, there is no explicit deny rule. Again, unlike network ACL, security groups perform stateful packet filtering. This means that it remembers the source of the request and the decision made for that request. If the request was allowed, the response traffic is automatically allowed. Next topic, virtual private network connection, also known as VPN connection. We know that if we attach an internet gateway to our VPC, we can publicly access our VPC. But what if we don't want to access our VPC publicly and want to access only from our on-premise network? A VPN connection allows us to do that. A VPN connection is a connection between a private network and a VPC established over the internet. With VPN connection, data is encrypted, and the VPC accepts only traffic coming from an approved network. A VPN connection is established using a device called Virtual Private Gateway, which we are going to talk about next. Next topic, Virtual Private Gateway. To recap, an internet gateway allows internet traffic into a VPC. On the contrary, a virtual private gateway allows traffic only from a private network by establishing a VPN connection. Next topic, AWS Direct Connect. AWS Direct Connect allows you to establish a dedicated private connection between a VPC and a private network. Previously, we discussed that a VPN connection is a private connection established over the internet. Therefore, it is not completely secure, and VPN traffic is susceptible to internet traffic congestions. But AWS Direct Connect connection is a connection established over the AWS network. Therefore, it's secure and faster. Similar to a VPN connection, a virtual private gateway should be attached to the VPC to allow direct connect traffic into the VPC. Next topic, Amazon Route 53. Amazon Route 53 is a DNS service. A DNS service translates a domain name to an IP address. Next, let's take a look at how DNS work. I'll walk you through step by step. Step 1. The process starts when a user enters a domain name to the browser. First, the browser sends a request to the DNS resolver, which is usually managed by the user's internet service provider, which is also called ISP. Step 2. DNS resolver forwards the request to the DNS root name server. It responds with an IP address of a .com name server. Step 3. DNS resolver forwards the request to the .com name server. It responds with an IP address of a DNS server of the site, such as Route 53 server. Step 4. At this point, we are very close to resolving the domain name. Then, the DNS resolver forwards the request to the Route 53 name server. It responds with the IP address of the web server which hosts the website. Finally, the resolution is complete. The DNS resolver caches this IP address so that it doesn't have to resolve the same domain name the next time. The cache has a time to live, which is also called TTL, so it expires after that amount of time. Then the DNS resolver responds to the browser with the IP address. Step 5. The browser sends a request to the web server with the IP address it got. Finally, the web server responds with a page. And that is how the DNS works. The final topic of this section, Route 53 and CloudFront. Previously, we discussed that CloudFront is a content delivery network which caches content on the edge locations for faster delivery. Route 53 can be associated with CloudFront to route users to the nearest edge location.